This next problem is an example where we would need to rationalize the denominator. We have the square root of 7 in the denominator, and that can't be simplified, and we can't just leave it there. So what we're going to do is multiply both the top and the bottom by the square root of 7. What this does is it gives us 5 root 7 in the numerator. And remember how we talked about if you multiply a square root by itself, there's a special trick. So the square root of 7 times the square root of 7 just equals a regular 7. So we get 5 root 7 over 7, and we can't simplify that any further because 5/7 is the simplest that fraction can go. So 5 root 7 over 7 is our final answer. For problem number 24, first thing we need to do is break up the radical. So we do the square root of 2 divided by the square root of 3b. So now we can't leave the square root of 3b in the denominator. So again, we're going to multiply by the square root of 3b over the square root of 3b. And that is going to give us 6b in the numerator, the square root of 6b, and then a regular 3b in the denominator. What you might want to do is cancel, because 3 goes into 6 and you can cancel out the b's, but because this 6b is inside the radical, you cannot cancel it with the 3b. Numbers inside the radical cannot be canceled with regular numbers. So this is our final answer. For this problem, we have the square root of 8 divided by 2x. See how the 8 and the 2 are both inside the radical? And we know that 8 divided by 2 is 4. To make our lives easier, we can simplify the fraction first before we break it up as the square root of 4 divided by the square root of x. Well, we know the square root of 4 is 2, and unfortunately we can't simplify the square root of x any further. And we can't leave the square root of x sitting in the denominator. So what we need to do is rationalize the denominator, multiply by the square root of x over the square root of x. That gives us 2 root x divided by a regular x. And that is our final answer. We cannot simplify any further. Try the following problems on your own. So pause the video, try the problems, and then restart the video to see how you did. For the square root of 1 over z to the 8th, let's first break up our fraction as the square root of 1 over the square root of z to the 8th. We know that the square root of 1 is 1. And let's think if we can simplify the square root of z to the 8th. So let's write that out as the square root of z squared times z squared times z squared, and we need one more, times z squared. Well, let's break it up as 1 over the square root of z squared times the square root of z squared times the square root of z squared times the square root of z squared. So we have 1 over z times z times z times z, which is 1 over z to the 4th. And that is our final answer. So it ends up, we didn't have to rationalize this denominator because we could simplify the square root of z to the 8th. 1 over the square root of 3. We have no choice here except to rationalize our denominator. So let's multiply by the square root of 3 over the square root of 3. So we get the square root of 3 over 3. And that is our final answer. Finally, let's take a look at problem number 10. We have the square root of 9 over 4x. So let's simplify as the square root of 9 over the square root of 4x. We can take the square root of 9, it's 3, and we can break up the square root of 4x as the square root of 4 times the square root of x. So then we have 3 over 2 square root x. All right, well, we did a good job simplifying so far, but we still have that square root of x in the denominator. So we need to multiply by the square root of x over the square root of x, which gives us 3 square root x up top. And then we'll just have a regular 2x in the denominator. The next thing we're going to talk about is adding and subtracting radicals. If two radicals have the same last name, then they are like terms and we can add them. So when I say same last name, take a look at problem number 26. See how we have a 4 root 10 and a negative 9 root 10? It's kind of like 4 root 10, his first name is 4 and his last name is root 10. And negative 9, his first name is negative 9 and his last name is root 10. So they have the same last name, which means that we can combine them. This square root of 13 is kind of the odd man out. He is not a like term. So when we do this problem, we can combine 4 minus 9 to give us a negative 5 root 10. That's still his last name. And then that root 13 just gets tacked on to the end. Before you start looking for like terms, you need to simplify all the radicals that you see, if they're not simplified already. So, if we take a look at number 27, we have 5 root 3 plus the square root of 48. So, we can simplify the square root of 48. 5 root 3 is already simplified. But we know that 48 is the same as 16 times 4. Oh, no, I'm sorry. 16 times 3. So that is going to turn into 4 root 3. So now we have 5 root 3 plus 4 root 3. They both have the same last name. So our final answer is 9 root 3. Try the next 3 problems on your own. So pause the video, try the problems, and then restart the video to see if you got the problems correct. 2 root 2 plus 6 root 2. They are like terms, so we can just combine them to get 8 root 2. 2 root 7 plus 3 root 63. We can't combine anybody yet, but I bet we can simplify the square root of 63. So 63 is the same as 9 times, oops, not 9 times 9, 9 times 7. And we know that the square root of 9 is 3. So we have 2 root 7 plus 3 times 3, which is 9, root 7. Now they have the same last name, so we can combine like terms and get 11 root 7 for our final answer. And finally, let's take a look at number 12. We have root 12 plus 6 root 3 plus 2 root 6. Well, we can't simplify 6 root 3 or 2 root 6, but we can break up 12 as the square root of 4 times the square root of 3. And we know that the square root of 4 is 2. So we have 2 root 3 plus 6 root 3 plus 2 root 6. And we can combine 2 root 3 and 6 root 3 since they have the same last name. So 8 root 3 plus 2 root 6 is our final answer.